welcome to VGD Academy. This is Anil Kumar, Faculty of Digital Electronics. Today I would like to teach one more new concept called Karnaugh map. Karnaugh map. Karnaugh map. Sir, Karnaugh map is also called as simply K map. We can simply call it as K map or Karnaugh map. What is the speciality of Karnaugh map and what is the use of Karnaugh map? If you can see, we have seen or we can say we have learned up to now Boolean algebra. Basically, in the starting classes, I told you about minimization of a digital circuit. To minimize any digital circuit or to make any minimization of a logical expression, we have three types of methods. First one is Boolean algebra, and second one is Karnaugh map, and third one is Quine-McCluskey method. We can also call it as tabulation method. Sir, we have learned about up to now Boolean algebra. There are few drawbacks in Boolean algebra. To overcome or to make minimization better, we just approach Karnaugh map. And let me try to explain what is the specialities of Karnaugh map so that we will understand the difficulties or drawbacks of Boolean algebra previous method. So basically, Karnaugh map simply we can call as K map. And so the second point, Karnaugh map is a graphical representation method. Graphical representation method. And then third one, it follows gray code. It follows gray code. And then it is used to it can use 3 digits or 3 bits, which are 1 and then 0 and also don't care. These are the 3 terms K-map can use to minimize any logical expression or any logical equation, we can say that. Sir, whereas coming to Boolean algebra, we have seen only these 2 variables, 1 and 0. 1 and 0, 2 variables we use to minimize a logical expression. Whereas coming to Karnaugh map, we are going to use one more digit called, this is called, we can say that don't care, or we can say a redundant term. The next point is it can minimize up to 5 variables. It can minimize up to 5 variables. These are the specialities of Karnaugh map. And also we just need to learn few words or few sentences when we are dealing about Karnaugh map. Sir, the first thing we just need to know what is memory cell. What is memory cell? And what is pair? What is pair? And what is quad? What is octet? These are the things we must know about when we are dealing about Karnaugh map. Sir, basically I told you Karnaugh map is a graphical representation method. It is a graphical representation method, so that based upon this graphical representation method, we supposed to solve all the problems, or we can say all the digital logical expressions we can minimize based upon graphical methods. Sir, basically this is a square box. We can say that I can call it as a memory cell. I can call it as a memory cell, which is used to store one bit, either 1 or 0. Either 1 or 0. It can store any one of the bit. And then what is pair? Suppose this is a memory cell. This is a memory cell. It is used to store one bit. It is 1. And suppose if I can add one more memory cell here, and then if I can fill this memory cell also with 1, if the 2 adjacent memory cells are filled with 1 digits, either 1 or 0, if we can combine these 2 cells, this is called pair. And now what is quad? Sir, suppose if I can take 2 more memory cells here, if I can take 2 more memory cells here and then if I can fill two more ones, and then combination of these four ones, we can call it as quad. And then coming to octet, suppose if I can add four more memory cells here, and if I want to fill these four more memory cells with one, and then the combination of these 8 ones, all memory cells are filled with ones, so that suppose if I can make connection, the 8 ones combination is called octet. This is called octet, and then this is called quad. This is called quad, and this is octet, and then this is pair. What I am trying to convince here, sir, the combination of two digits, either zeros or ones, we can call it as a pair. And then combination of 4 digits, it may be either 0 or 1, we can call it as a quad. And the combination of 8 bits, it may be 1 or 0, it can be called as octet. Sir, based on this knowledge, let me try to explain few more things here. Sir, here basically K-map can be available with 3 forms or 4 forms. Let me tell. Here the first thing, it can be available with 2 variable, and then it can be available with 3 variable, and also it can be available with 4 variable, and also it can be available with 5 variable. Sir, what are the 2 variables? If you can really asking me, the 2 variables are, we can say A and then B. To form a logical function, we can call it as f of a comma b, and then here the b can be called as here LSB, and then a can be called as MSB. This is called least significant bit, and then a is MSB, most significant bit. Here for 3 variable, the function can be available a comma b comma c, and here LSB is c, we can say LSB, and then a is MSB. And coming to 4 variables are f of a comma b comma c comma d, and now here d is LSB, and then a is MSB. Coming to 5 variable, I told you in the class starting itself, here K-map can be available up to 5 variables. So now here, what is the 5 variable? F of a comma b comma c comma d comma even e also. Here e is, we can say this is 32-bit K-map, and then e is LSB, and then a is MSB. So this is what. Sir, what is 2 variable, and then what is 3 variable and 4 variable? Suppose while we are solving the problems, when we are dealing with 4 variable or 5 variable or whatever the variable K-map it may be, suppose if we can make pair, we may be able to reduce one variable. We may be able to reduce one variable, and then while solving these 2 variable, 3 variable, 4 variable, 5 variable K-map, if we can make quad, we can say if we can make quad, we can reduce 2 variables. We can reduce 2 variables, and then if we can make octet, we can say we can reduce up to 3 variables. Moment when automatically this reduction happens, automatically output logical expression also reduced, and then output logical expression reduced means we can say number of input requirements is also reduced. If input requirements is also reduced, size of the circuit will be reduced. Once size of the circuit is reduced, cost of the circuit is also reduced. Once cost of the circuit is also reduced, we can say power requirements, we can say cost of the circuit reduced means we can say power requirement power requirement is also reduced, and then physical space is also reduced. We will try to know what is the pair, quad, octet in further classes while we are solving Karnaugh map problems. Thanks for watching. Please do subscribe.